Hello guys, welcome back to the VDC space. Today we're going to be modeling a portal frame using Dynamo visual programming. So this is a very much exciting episode. This is our very first episode of visual programming. So I'm pretty much excited for it. So we're just going to keep it as simple as we can. We're going to model up a portal frame, level of detail 300. We are not going to do connections and all that. I'm just going to show you the logic behind creating a much faster workflow in terms of modeling portal frames for your structural warehouses and all those structures like factories and all that. So without further ado, just jump into Revit 24 or 23. So I just open up the construction template, and then the first thing I'm gonna do before opening up Dynamo, I'm just gonna load in my families that I'm going to use. So I'm just gonna go to Insert and say Load Family, Metric Library, UK Contents, and then I'm gonna start with my structural columns and go to Steel and then British Standards. And then I'm going to load in UB, Universal Beams columns, and say open. And then the column I'm going to load in, it's going to be 610 by 229 by 101 Universal Beam. So it's going to be 610 by 229 by 101. So it's going to be this one and say OK. And then I'm going to load in my beam. So I'm going to go to metric library and say UK, and then structural framing, and then steel, British standards. I'm just going to enlarge this and then go to universal beams and say open. So for our beam, we're going to go with 533 by 210 by 92 universal beam. So it's going to be 533 by 210 by 92 universal beam. So it's going to be this one and say OK. I'm going to override the existing version and its parameters. And now it's time to open up Dynamo. So I'm just going to go to manage, and then under manage we have this visual programming, and then under that above that we have Dynamo. So we're going to open up Dynamo. So I'm just going to enlarge this, and now we are in Dynamo. So I'm just going to open up a new project, and then this is the interface of Dynamo. Now, the first thing we're going to do before generating our nodes, we're gonna load in a package that will make it easier for us in order for us to generate our nodes for our portal frame. So I'm going to go to packages and say search for a package, and then you can search your package here by typing in structural frame. Structural design, sorry. So you're going to say structural design, and then the option of structural design is going to appear there. I already loaded mine in. So you're going to install it. Remember, install it. And then after you install it, it's going to appear under add-ons. So here we already have generative design, sophistic analysis, and then this is the structural design add-on I loaded in from Dynamo packages. So while we are in structural design, you're just going to drop down like this, and then go to drop down the model, and then you're going to drop down the frame. So this is what we are going to use. Now, the first thing we're going to load in is we're going to go with by width, height, and angles. So this is basically our portal frame. We have the insertion point, which is set at 0, 0, 0, 0 for X, Y, and Z automatically. And then we have the vectors, and then we have the width, height, and angle. So in this instance, we're going to use the width, height, and angles. But in order for us to generate variables for the width, height, and angles, we're going to have to load in our integer sliders. So our integer sliders are basically numerical numbers, whereby we have to connect them to these variables in order for them to have an effect on our 3D geometry. So I'm going to right click on my mouse and type in integer. So we have the sliders. You're going to select it. And then this is our first integer slider. So I'm going to select it and then right click on it and say rename. And then I'm just going to rename this one to width. and then I'm gonna accept. And then when you go to the left, you see we have this drop down arrow where you can set up your parameters or your variables. So for the minimum of our width, I'm gonna set it to 10,000 millimeters, and then the maximum I'm gonna set it to 40,000 millimeters, and then the step, which is the increment, I'm gonna set it to 1,000 millimeters, and then I'm just gonna reduce this. Perfect. And now I'm gonna connect this integer slider to width, and as you can see, it took an effect on that. So I'm just gonna set this to manual in this instance. And in order for you to zoom in, zoom out for when it comes to your 3D geometry, you have to switch between these two. Enable background 3D so that you can zoom out and zoom in. And also you can switch back to enable graph view navigation in order for you to see your nodes. So this is what we have. So I'm just going to switch back to our nodes. So I'm going to load in our second integer slider. I'm going to right click and say integer again, slider. And then I'm going to right click and say rename. And then I'm going to rename this one to height. Accept, and then I'm going to drop down this arrow, and then I'm going to set the minimum to 8,000 millimeters, and then I'm going to set the maximum to 12,000 millimeters, and then I'm going to set the increment to 1,000 millimeters. Perfect. And then I'm going to connect this to height, and then I'm going to generate another one, integer slider, and then I'm going to right click on it and say rename, and then I'm going to change the name to angle. So it's going to be the angle for the roof basically, and say accept. And then I'm going to drop down this. So the minimum angle, I'm going to set it to 5 degrees. The maximum, I'm going to set it to 45. And then the increment, I'm going to leave it at 1 degrees. And then I'm going to connect this to angle. So I'm going to set this to automatic in order for it to generate automatically. And this is what we have so far. So if I just change the orientation, so this is how our portal frame looks. If I zoom in and zoom out, so this is what we have so far. And I'm just going to switch back to our nodes. So uh, when you uh, when you adjust the integer sliders, you can see that it takes effect on your 3D geometry that you just generated. So it's very much intelligent. So this is how it works. So I'm gonna set this back to I'm just gonna leave it at 20,000 millimeters. I think it's fine. So the next thing we're gonna do is we're gonna generate our the next thing we're gonna do is we're gonna generate our frame copy. So we're gonna have to load in our purlins and our side and our X bracings and also our side and also our side members. So in order for us to do that, I'm gonna go with so I'm gonna say create 2D. Actually, no, it's not this one. I'm just gonna remove this one. I'm gonna select this one, which is copy. So copy 2D frame. So this is I've loaded my copy 2D frame. In this instance, we're gonna use only number of times and also the spacing. And how will this take effect on our portal framing? So it is gonna generate multiple of these members of this frame, multiple of these frames, and then you can adjust the spacing between them, and then it's gonna create multiple base. So the base, you take it as the spacing between two different frames. So let's see how we can apply that. So we can generate another integer slider. So you're gonna right click and say integer and say slider, and then I'm gonna right click and then rename it. So I'm gonna rename this one to number of base and say accept. and then I'm gonna connect it to number of times, which can be taken as number of base, and then we're gonna generate another integer slider, and then I'm gonna right click and say rename, and then I'm gonna rename this one to spacing, base spacing, and say accept, and then I'm gonna connect this to spacing on the frame copy. Perfect. And now for the number of base, I'm gonna drop down this arrow again, and then I'm gonna set my minimum to 1, and then I'm gonna set my maximum to 10. And then my increment, I'm gonna set it to 1. I think it's fine. And then for my base spacing, I'm gonna drop down again and then set the minimum to, I'm gonna set it to 4,000 millimeters. And then my maximum, I'm gonna set it to 8,000 millimeters. And then my increment, I'm gonna set it to 1,000 millimeters. And then I'm gonna drop this. So if I extend the number of this is what we have. So if I extend the number of, increase the number of base, so I'm gonna have to connect this to my frame by width and height and angles. So in order for me to do that, I'm gonna connect it like this. So this is what happens. Let me just switch this and then rotate this, then switch this back on. So this is what we have. So everything is working perfectly. We have no errors so far. So if I increase the number of base, this is what it does. When I decrease it, this is what it does. When I increase it, this is what it does. And then also the base spacing, if I increase it, this is what it does. And if I decrease it, this is what it does. So this is a perfect script so far. Now, the next thing is we're going to load in our purlins. So for our purlins, we also have the node for that. So we're going to load in our purlins. So we have the frame purlins. And then for our frame purlins, we're going to use the number and also the rafters. Those are the only things that are irrelevant in this situation. So for the for the rafters, we're gonna connect it towards our beam on our frames, and this is what happens. They are automatically generated. So you connect the rafters to the beams on the frame copy, and also the numbers. You're gonna have to create another integer slider for the number of purlins. So you're gonna right click and say integer slider, and then you're gonna set your variables. So the minimum you can set it to 5. Actually, I'm gonna set it to 10, and then the maximum I'm gonna set it to 20. And then the increment, I think it's a fine at 1. Actually, the minimum I'm gonna set it to 5, and then the maximum to 20, and then the increment to 1, and then this is what we have. So the number on our frame purlins, I'm gonna connect it to the integer slider of our purlins. So this is what it does. And now the next thing is we're gonna generate our X bracings. So for our X bracings are gonna be based on the first bay. So this is the first bay, and then this is the last bay. So bay 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want our X bracing on bay 1 and also bay 10. So we're gonna load in X bracing. And now for our X bracing, we have points and zones. Those are the only things that are relevant in this situation. So for our X bracing, when it comes to the points, we're gonna connect them to frame purlins points. So we're gonna take the points from our frame purlins, and then we're gonna connect it to the points of frame X bracing. And now for the zones, it's gonna be a different situation. We're gonna have to create a code block in order for us to create a sort of like sort of like a position of our expressing where they are going to be situated, which is bay 1 and also bay 10. So I'm going to double click and then double click on our interface, and then it's going to automatically create this node for code block. And now you're going to say enter the code here. So for your code, you're going to say bay 1, you're going to type in 1, and then you're going to say comma. And then in order for you to create an increment whereby you want your expressions to appear on the last bay, you're going to type in bay, and then you're gonna close it down by actually you're gonna first use a square bracket and then type in 1 and say comma and then say bay and then close rectangular bracket, and then this is what you have. And then you're gonna connect your bay to your zone, and then you're gonna connect your zone to your code block. And now for your X bracing, so yeah, your points, you're gonna connect it to your points, and then actually this is let me just remove this. So we're gonna have to search for number of base. Now you can take a number from the number of base, you're gonna take it and then you're gonna connect it to code block, and then from code block you're gonna connect it to zone like this. So this is what we have. So if I zoom in, this is how it looks. Perfect. Now if I go back to my notes, and this is what we have so far. And now the next thing is we're going to have to generate our site rails, which are going to be based right there. And bear in mind, if you set this to automatic, it already, if I open up the 3D view in Revit, it's already been generated in Revit. So this is how it looks so far. So if I go back to Dynamo, and we can go on with our coding, with our programming. So for the site rails, we have an option also for the site rails, which is a site rails eaves beam. So we're gonna load it in, and then in this instance we have columns and heights this side, and also beams and points on the right hand side. And now for your columns, you're gonna connect them to connect them to when you go to the frame copy, you're gonna connect them to the columns on the right hand side on the frame copy. So you're gonna connect them like this. Let me just move this side. And then for your heights, it's gonna be a different situation. You're gonna have to generate a code block in order for you to create an interval like you did for the base. So you're gonna double click for your code block, and then you're gonna start off with an 300 millimeter offset, and then you're gonna double click two dots, two full stops, which is a sign of creating a range for your offset for the number of rails you want on your sides. And then you're gonna type in height, and then after you type in height, you're gonna press another two full stops, two dots, and then you can make it 800 or 1000. So this is your interval, and then these are your ranges. This creates your range, and then this is your first your bottom offset, your start offset, if I may put it like that. And now, so your code block, you're gonna go back to the height integer slider that you created right in the beginning, and then you're gonna connect it to this code block. And then this code block, you're gonna connect it to the height of the frame side rails eaves beam, and this is what it generates. Those are your side rails. Perfect. And now we are basically done with our Dynamo script for our portal framing. But the most important part, of course, is to load in our geometry, solid elements when it comes to this, and I'll show you guys how we can do that. So we're gonna start off with our beams. um, with our beams. And in order for us to generate our beams, which are gonna detect this portal frame, we're gonna go with beam. We're gonna Let's just close this down and then go to Revit, drop down Revit, and then you're gonna drop down elements. And then when you scroll down, you're gonna go to structural framing, and then we have beam by curve, brace by curve, column by curve, and then you have location. So we're gonna start with beam by curve, and beam by curve we have the curve, level, structural framing type, and then the structural framing on the right. So we're gonna we can just right click also, and then right click and then search for levels, and then you're gonna click on levels, generate levels. Before we continue, just uh, minimize Dynamo, go to the south elevation on Revit, and then rename your level to 00 dash foundation. Enter. And then the second one, you're gonna name it 01 dash eve. Enter. And then you can change the height to 6,000 millimeters, or actually you can just grab it and then move it upwards like this, so it's gonna be 8,000. Select it, maximize 3D extend, maximize 3D extend. And now go back to the 3D view. This is what you have. Now you can go back to Dynamo. So we're gonna start off with the levels. So you can set the level to Eve, and then you can connect the levels to the levels of structural framing beam by curve. And then for the structural framing type, you're gonna right click and then type in structural framing. So we have this option of structural framing type, and then you're gonna load it in, and then you're gonna change this to the beam that we generated, which is 533 by 210 by 92. And then you're gonna connect it to structural framing type on structural framing beam by curve. And now the only thing left to do is to connect your curve. And now your curve is gonna be connected to your beam on. When you go to frame copy, you're going to connect it to your beam, and then it's automatically generated. So when you open up Revit, let me just minimize. When you open up Revit, this is what you have. So it automatically placed those elements on your portal frame. So we are almost there, guys. When you open up the Dynamo again, you're going to apply the same logic behind when it comes to the bracings and the columns. So let's start with the columns. I'm going to open up column by curve, right click, search for level, load in level, and then you're going to set it to Eve, connect it to this level, right click, and then structural, you're going to search for structural column types. And then you're gonna load the one that we loaded in at the beginning, 610 by 229 by 108, and then connect it to structural column type. And then the curve, you're gonna connect it to the columns on the frame copy, and then you're gonna connect it like this. And now when you minimize Dynamo and then go to Revit, this is what we have. And now I'm just going to select my column, right click and say select all instances visible in view, and then press spacebar on my keyboard just to change its orientation. Actually, why did it disappear? Okay, yeah, the orientation is changed and this is how it looks. So I'm just going to open up Dynamo again. So structural framing operation failed. I think that's because I changed the. Okay, everything is fine. I think it was because I changed the orientation and all that. So yeah, we can just continue. And then After that, we're gonna place our X bracing and also our side rails. Now for our X bracing and our side rails, I didn't manage to load in our families for that, so I'm just gonna go to insert and say load family metric library, and then for our X bracings, I'm just gonna go to structural framing and then steel, and then I'm gonna go to British standards and then say circular hollow section open, and then I'm just gonna use 76.1 by 5 and say open, and then I'm gonna go back to Dynamo, and then I'm gonna say brace by curve, and then brace by curve it's generated. I'm gonna right click and say level, load in level, right click again, and then I'm gonna type in brace, X brace. Actually, no, I'm gonna type in structural framing, types, and then this is the circular hollow section, and then I'm just going to select E for my level, connect it, and then my structural framing, and then my curve, I'm going to connect it towards so where's the X bracing? So I'm going to connect it to my X bracing. So this is the curve. I'm going to connect it to our X bracing. So if I open up Revit, those circular hollow sections are generated. Perfect. And now I'm going to open up Dynamo again. And then for my side railings, same logic. I'm just going to go to brace by curve and then right click, levels, set the levels to Eve, right click, structural framing, types. And then I'm going to set this one to, actually I haven't loaded the side rails, so I'm going to go to load family first, metric library, UK contents, structural framing, steel, and then British standards. And then I'm just going to enlarge this, and then I'm going to load in PFC, parallel French channels, and say open. And then we're going to use 150 by 75 by 18 and say okay. I'm going to go back to Dynamo, and then the structural framing type 150 by 75 by 18 PFC, and then I'm going to connect it to the structural framing type, and then the levels to levels, and then the curve I'm going to connect it to the side rails. So the frame side rails, I'm going to connect it to the beam side, and then if I minimize this, go back to Revit, so this is what we have. The last thing we're going to do is the purlins. So if I open up Dynamo again, I'm going to go to the beams. Let's go with the bracings again. Right click, search for levels, set this to Eve, connect it to levels, right click again, structural framing types. CHS, I think it's still fine, 76, but actually we're gonna go with PFC 150 by 75 by 18, connected to structural framing, and then the curve you're gonna connect it to your purlins. So we're gonna have to look for that node of purlins. Everything is so messy right now. So where is the purlins? So you're gonna connect it to the purlins. If you minimize, this is what we have. Now obviously the purlins, you're gonna have to offset them in order for them to stand on top of these beams, and yeah, this is what we have. So guys, I hope you enjoyed this tutorial. I certainly did myself. This is our script. Make sure you save this as, and then you can save it as your own script. I'm going to post more content when it comes to generating much faster workflows in terms of creating BIM models and 3D geometry. So stay tuned. Please like, subscribe, tell your colleagues, tell your friends to visit my channel. I need as many subscribers as I can. Let's get to 10,000 subscribers. Let's get to 5,000 for a start, guys. Please like and subscribe, and I hope you enjoyed this tutorial, and I'll see you on the next one. Peace.